In the vast, silent theater of the cosmos, there are rules. Unbreakable laws written in the language of mathematics and physics, governing everything from the spin of a lonely electron to the grand waltz of galaxies. The most fundamental of these laws is the law of causality, of time itself. The universe, as we measure it, began 13.8 billion years ago in the Big Bang. This isn't just a theory. It's the bedrock of modern cosmology, a cosmic speed limit for age. Nothing can be older than everything. It's a simple, elegant, and forbidden line to cross. So what happens when we find something that seems to have crossed it? What if I told you that hurtling through our own galaxy is a star that astronomers have stared at, measured, and remeasured? A celestial object that, for all intents and purposes, appears to be older than time itself. This is the story of a cosmic impossibility, a star that shouldn't exist. Astronomers call it HD 140,283. The public has given it a much better name, the Methuselah star. Located just 190 light-years away in the constellation Libra, it's practically our next-door neighbor in galactic terms. And it's moving. Fast. At a blistering 1.3 million kilometers per hour, it's not orbiting peacefully within the Milky Way's disk like our sun. Instead, it's just passing through, a transient visitor from another time and place. Its trajectory tells a story. This star is part of the galactic halo, a sparse, spherical cloud of ancient stars that encircle the main galactic disk. These are the first-generation survivors, the relics that formed when the Milky Way itself was just a baby. And this is our first clue to its impossible age. How do you tell the age of a star? You can't just cut it open and count the rings. The process is a masterpiece of cosmic detective work. One key piece of evidence is a star's metallicity. In astronomy, a metal is any element heavier than hydrogen and helium. These heavier elements are forged only in the nuclear furnaces of stars and scattered across the cosmos when they die. A star like our sun is rich in metals, meaning it's a newer model, built from the recycled ashes of many previous stellar generations. The Methuselah star, however, is what's known as an extremely metal-poor star. It's made almost exclusively of the raw hydrogen and helium that filled the universe right after the Big Bang. It has 250 times less iron than our sun. This purity is a birth certificate, proving it was born in the absolute infancy of the cosmos. Using its brightness, its composition, and our best models of stellar evolution, astronomers can calculate how long a star must have been burning to reach its current state. And when they first did the math for HD 140,283, the numbers came back wrong. The initial calculations put the star's age at a staggering 16 billion years. For a moment, it was as if a fossil was found that was older than the Earth itself. The universe is 13.8 billion years old. The star simply could not be 16 billion years old. A law had been broken. The discovery sent ripples through the astronomical community. Was our understanding of stellar evolution wrong? Was our measurement of the universe's expansion, the very foundation for its age, flawed? Or was something else going on? Naturally, scientists launched a full-scale investigation to solve this paradox. Every variable was placed under the microscope. The first suspect was distance. The star's apparent brightness from Earth is a key part of the age calculation, but to know its true, intrinsic brightness, you need to know exactly how far away it is. Early measurements had a significant margin of error, so they pointed the Hubble Space Telescope at it, making one of the most precise distance measurements ever. This refined the data. Then, they looked closer at the star's chemistry. While it was metal-poor, it wasn't metal-free. It contained a slightly higher than expected amount of oxygen. This small detail changes how a star's core burns, how heat radiates outward, and ultimately, it affects the age models. After years of recalculation, factoring in the precise distance, the oxygen content, and even tweaking our understanding of nuclear reactions inside these ancient stars, a new age was determined. The Methuselah star is now estimated to be 14.27 billion years old, give or take a margin of error of about 800 million years. The paradox was softened, but not solved. At the lower end of its age estimate, It just barely fits within the age of the universe. But just barely. It means this star must have formed a mere 100 to 200 million years after the Big Bang, pushing right up against the theoretical limit for when the universe had cooled enough for the very first stars to ignite. The law wasn't broken, but it was bent to its absolute breaking point. HD 140,283 went from being a cosmic criminal to the universe's most haunting witness, an entity that saw the first light of the first galaxies flicker into existence. It challenges our models, forces us to refine our timelines, and stands as a stark reminder that the universe is still full of impossible truths waiting to be found. The case may be closed, but the star's very existence forces us to ask, what else from that impossible dawn is still hiding in the dark?